You think so? Fair. I think it's easier mathematically, but harder with all the theorems and stuff, which, I mean, that's part of math, so I don't know. Okay, different for sure. Here we go. We are going to jump right into some algebra stuff and immediately use it. We have one big problem we're going to work today, just for the record. So here we go. You guys are going to help me just recall a few things. And this is still the same section, just so you're aware. No new section. We dealt with centroids and orthocenters. We're just continuing. Okay. How do you find, what is, if you see this letter written somewhere, what is it typically denoting or telling me? Could be. And what about algebra? So this is commonly slope, right? And how do you find slope between two lines? Does it really matter if I do y1 minus y2, or can I do y2 minus y1? As long as this changes too. Okay, so we have this idea of slope. Okay, let's go a step further. How do you find a perpendicular slope? If I have some line and it's perpendicular, which means it forms 90 degrees, how do we find that? So first off, if I have a positive slope and I want to draw a perpendicular to it, I know that it has to be negative. Or if I have a negative slope, its perpendicular would have to be positive, right? So I already see that it's the opposite sign. So we're just going to say, okay, if I want the perpendicular slope, it is the opposite. And then there's one other weird part. I call it the whoa, but there's a real mathy word for it. Or I actually do this is more commonly what I think of. If you do this with a fraction, you flip x and y, or upside, like you do it upside down. What's that real word? Nice. Recip. And I would take that honestly. The real word is reciprocal, but it's just flip the fraction, change the sign. This is how we guarantee it's perpendicular. Now, additionally, a couple more little pieces that we will need. How do you find the equation of a line? Like if I said, what is the equation of a line? Can you give me one? That is a natural, and everybody's always going to answer this one first. What is the name of this? Slope intercept. Why is it called slope intercept? Yeah, because it has literally the slope and the intercept. And it's a y-intercept. Nice clarification there. Is there another form of an equation? So if I have a point and a slope, how do you find that equation? y1 equals m. Good. Now I'm just going to say this is point slope, and I'm going to be more, we'll say it here, this is point slope. And we talked about this stuff earlier in the year. It's been a while since we've had to use it. You certainly did a lot of this in Algebra 1 last year. We did a lot of it in Algebra 2 at the beginning of the year. But I'm just going to put one more little clarification where x1 comma y1 is on the line. So it's a point that is on the line. Okay. I think this is the last little thing we needed. Now, there is a bigger idea that we're going to see. We haven't had to do this year. Lily will remember this, but I don't know if everybody else will because she's in Algebra 2. Have you ever solved a system of equations? Do you remember what they are? And that's okay. If I had two lines, and you don't have to jot this down, but I just want to give us the basic setup for it. In this box, do not draw it, okay? This is just us thinking. If I have a graph, I could conceivably graph a line, right? So I'm just going to make it up. Let's say here's this line. We'll call this y equals, I don't care what it is, it's y. y1 maybe. If I draw another line, maybe it's this one. Do those two lines cross? And do you agree that this is the point where they cross? And then even more than that, at this point where they happen to meet or cross each other, do they have the same y value? So you say that, but let's try this real quick. Do they meet at a single point? So if my point was a comma b, and I'm just making this up arbitrarily, they both have a y value of b here. They also both have a y value of a, or sorry, an x value of a at this point. So they do have the exact same values. So if I set these two equal to each other, and it depends on how they were written, we're probably going to get an x value where this happens. Does this look like something you remember doing from Algebra 1? Okay, you've done it on the calculator. You probably did it a bit with graphing. There's a much nicer way to do it than graphing. I'm going to throw out a couple more words, and we're just going to, realistically, we'll review them as we're doing the problem. Anybody remember the methods to solving these? One of them is called substitution. The other one's called elimination. Now, the good news is we're going to solve a system today, and we're going to review a bit of the algebra. It's going to happen with substitution. If you didn't get it during Algebra 1, that happens. But we got to get it now. So if you didn't get it before, or if you don't get it when we're going through it, what's your job as a student? Bet, bruh. Cool. All right. You guys ready to do a problem? Baller. Do you want to do our Feelings Friday before? Because it's like a 15 or 20-minute problem. It's actually Wine About It Wednesday. But, okay, deal. So, as we're looking at these, the only center that we haven't really dealt a ton with is our orthocenter. And we're going to do it right now. Okay, I cannot stress enough. We don't do a ton of algebra stuff in here. We do a little bit of factoring we've done on and off, but we haven't done lines and things for quite a while. We're going to do lines and things right here. And we didn't take a really algebraic approach to all of these. But if I give you any triangle, I think it's reasonable if I ask you to find me the equation of a median or find me an equation of something else. Now, what we're going to do for this first problem is, and we can do more of these if we need, so I'm just going to say given, and not a proof until you see the word prove or show, given, let's say it's triangle ABC with, and I'm going to write these like vertically just so they're easier to see. Let's say A is the point 0, 0. B, we'll say, is the point 10, 4. Good, buddy. And C is the point 8, 9.
What did you say after you said 10, 4?
Good, buddy. I mean, it's not a song. 10, 4 is how you say it's like cop talk or radio talk for yes. I don't know why this one has a parenthesis. I'm going to move it. Okay, we have 3 points, A, B, and C, and here they are. We are going to find on this the orthocenter. We're going to call this A. If we have to do another one to find a different piece, we can. But here we go. A, I want us to find the orthocenter of triangle ABC. So the orthocenter is the intersection of all the altitudes or the heights of our triangle. So what do you think might help us to make sense of this? So Ray says a picture. Would a rough sketch help, do you think? Now, it doesn't have to be perfect. If you want to make it perfect, I'm probably not going to wait for you. I won't. So we have two options. I can either just do a really rough one also, since you are, or because I have all this graph paper, I can actually do it perfectly, kind of well. And then you guys will just have a rough picture. Let's do that. Okay, I'm going to spend a moment to make this fairly nice. So I notice that all my x's and y's are positive for 0, so I'm only in quadrant 1 right now. And let's just plot these points. If I want to plot 0, 0, I think it's right here. There's point A at 0, 0. I don't know why I'm using different color, but that's okay. B is the point 10, 4. So this looks like the point 10, 4 to me. 10, 4. And C is the point 8, 9, which is way up here. C is 8, 9. First thing I'm concerned about, do we have a triangle? That's a good sign. Okay. Do you think it's a right triangle?
Yes.
It kind of looks like it. Is that enough? No. Now, there's a couple ways we could check if it were a right triangle easily. Not really our focus, but it's just something nice to think. Oh, you're right in your way. My bad. Okay. So here's the deal. We're going to find the orthocenter of this. Now, I'm going to do all the scratch work, and hopefully it fits. I'm going to do it all right here, just because I want to be able to keep it up so we can see the triangle and stuff. Could we roughly sketch, and I don't want you to do it, but I can. Could we sketch, and I guess you can we sketch an altitude of these? Could we sketch a height from one of these three sides? Now, here's what I'm thinking. There's one segment, there's actually two segments there that are the easiest to find the slope of, because if we're starting to think about these, I don't really care what side we look at first, but I'm going to draw an altitude from B first. So, and this is weird, Carson, you weren't here yesterday. If we have an altitude from B, don't sketch this, but I'm just looking. Is this the same triangle, just flip the other way, roughly? So if this is point B, if this was flat ground and you were to hang a weight on a string, do you agree it drops straight down? And that would be my height of my triangle or my altitude. So you weren't here when we talked about it in here, but do you agree that's how we would get the altitude out? Okay, so I'm going to do the same thing, but I'm not going to rearrange a triangle. If I wanted to sketch two altitudes, I could, and it turns out they intersect at a single point. Now, I'm going to, by arbitrary choice, I'm going to sketch this altitude. And what other one could I sketch from? And I'm going to let this run through, so we'll do this, because maybe it runs through. I drawn the altitude from B. Where else can I draw it from, or would you like me to draw it from? I could draw an altitude from A, or I could draw an altitude from C. From C, and this one's weird, it'd be perpendicular. I don't know if this is really a right angle or not. It might be. If it's not, if we extended this out just a hair, and we did this yesterday, I believe, if we extended this side out just a little bit to see, oh my gosh, oh, it's so slow. If we extended it out just a little bit, I can see that there's now a right angle here. Now, our altitude could be inside or outside, Carson, because if we think about like a triangle like this, and we'll even have it sitting down, but this triangle, this is the height of it. Would you agree? Like, and it's weird that we have to extend it, but that's all that's happened. Now, if I drew the third altitude on this triangle, I know that it would intersect at this point again. Do I need to draw the third then? Like, if I'm just eyeballing it, I think I've identified where my orthocenter would be. It'd be here. I don't need the third altitude anymore. Can we all agree with that? Okay. So we need to keep our work organized because I'm going to be honest, this is a pretty long problem. Now, they'll go much faster when you're doing it on your own. Depending on how comfortable with your algebra you are is going to dictate how quickly this goes. If I said find this equation and find that equation, could you guys do it? Let's do one together, and then I'll have you guys do the other one then. So I don't care which one we start with. Do you guys have the same two altitudes on yours? You might have all three of them, but at least two of them. So help me make a decision here. I'm going to use only the two that I have. Which one do you want me to help you find the equation of? The green one or the fuchsia one? So check this out. We're going to be very specific. If I'm looking at the green line and I want to keep my work organized, I'm thinking about an altitude from which point? The green line. Where's the vertex that I drew my altitude from? B. Does everybody agree with that? This is like arbitrary choice. We just chose green and said, okay, well, that's the altitude from B. So we have a little bit of thinking to do here just to make sure we can see all these pieces. If this is the flat surface, if this is my height, then this is a right angle right here. Okay. Well, if I want the equation of this line, I already know it runs through this point, so all I need is a slope. Because if I have a point, point slope exists. How do we determine if the slope of this green line? What does it have to be perpendicular to? So I'm going to draw it here, and I'm still going to ask the question. What is this green line? What did we just draw it was perpendicular to? Which segment? AC. Does everybody agree with that statement? Now, all this is just the thought process that you don't really have to include when you're doing the problem on your own, but it's nice to have this first time especially. Okay, help me then find the slope of AC, because if I can get the slope of AC, I can just flip it upside down or flip it around and change the sign, and now I get my new slope. So we have recognized this. Help me find the slope M of segment AC. And there's something really awesome about this. If I wanted to use, I got another one for you here if you need it. If I wanted to use y2 minus y1, I could, but there's something really special about this. What's A? Like if I'm trying to find this slope, it's at the origin already. So I don't even have to do y2 minus y1, but we could. To get from A to C, how many up do I have to go? So 9 up, and how many over? So 9 over 8 is the slope there. Because we had the origin, it's super easy. I'm going to make it clearly a 9. 9 over 8. Drew, are you okay with that? Work along with it too. Don't just listen, okay? Make sure you're doing it. Okay. There is a problem similar to this. Is there a problem like this on the final? No. Something with an orthocenter, I'm sure. Okay. For this, this idea will show up. It wasn't on yours. It doesn't mean it's not going to be on everybody else's, just so you know, because I'm going to have a different version. Okay. The slope of AC is this, which implies to me the slope, and this is just a new my subscript. I'm going to say the altitude, ALT, from B. And I'm just going to make sure I don't lose track of stuff. You do not have to do the same stuff. This is just how I keep track of that. This slope that I'm writing is the altitude from point B. If you have a different way, I'm cool with it. If you flip that fraction, what does it become? 8/9. And what if it's the opposite? This is a positive, and its opposite is negative. So I now know the slope of this is a negative 8/9, which it certainly looks like a negative slope to me. That seems reasonable. Okay, we have a point. We have a slope. What point does altitude have to run through, guaranteed? Through which point? When I draw this green one, you have to be able to tell me a single point that you know exactly what that point is. Anywhere on this green line. Good, buddy. There it is. I can't stop it, just so you know. So it's going to keep happening if you guys just read it like that. Well, the good news is a moment ago, it's not on my screen, but it's probably on your page. Do we have a form of an equation that if I have a point and a slope, we can find it? So what is that equation? Y minus something. Y1. And if you want to write it again, we can. Or what's Y1, the value that I'm passing through? 4 equals, what do we just find our slope was? And it is x minus, what's the x value of that point that we're using? 10. Love it. Now, in a different color, I wouldn't do it if I didn't have a different color, but notice these are just these values. Every time, they're those two values. It's whatever point we want it to run through. Can we solve this for y equals? In fact, we're going to, and you're going to help me. Vincent, I want to solve this for y equals. What happens on this side? What does this operation tell me to do? Distribute. So when I distribute, I think I'm going to keep a y minus 4 on the left equals negative 8/9 x plus 80/9. It's kind of ugly, but it's there. Okay, we're one step away, and you're about to see something that's going to look a little wonky, but we're going to make sure that we're all on the same page. If I want to solve for y now, what should I do?
Plus 4 to 80.
So check this out, and I want you to tell me exactly what I've done. I'm going to write plus 4 here, and I'm just showing this middle step, but I'm going to write this over here. Why would I do this? And what have I done?
You changed it to 9 with that.
So kind of. Is this still 4? So I'm really still adding the same thing to both sides. And because this is already a fraction, if you want to add two fractions, you have to have a common denominator. So I've just rewritten it with its common denominator right here to save a little bit of work. Okay, so the left side is y equals, and let's see, negative 8/9 x plus, what's 80 plus 30? Good, so 110 plus 6 more gets me to 116. I think it's 116 over 9. And it doesn't feel like it goes into it to me, does it? Because 9 times, doesn't feel like it. Okay, bummer. That's not the end of the world. We now know that this green equation is y equals negative 8/9 x plus 116 over 9. Whether you label it here or not is up to you. Okay, now I'm looking for the point where this green line intersects the purple one. So it's now your guys' time to shine. That purple line is the altitude that is drawn from where? from C. Okay, your job, and I'm going to give you guys a couple minutes, is I want you to find me the equation of the altitude drawn from C. So you get to fill in all this. If you need help starting, we can, but I want you guys to try it, talk it out. I encourage you should hopefully be talking with one another. Cool. I'm going to give you a minute. Find me the altitude or the equation of this purple line. And it could keep going forever too. Find me that equation. We'll give you a moment. I'll give you a moment and ask questions if need be. Because I'll add 9 to both sides now. Plus 9 and plus 9.
You know what? I did the two negatives, but I put it to a negative still.
Okay. So I'll give you a second. Let's make sure that we're on the same page. I don't think I've made any mistakes, but I'm human too. I think so. I mean, maybe. I'm pretty sure. But I guess if I was a robot, I'd probably be pretty sure too if I was a good robot. So I don't know. I think I'm right. Okay. Kind of a long problem. Are we done? Do you have a mistake somewhere? Did you get the same thing that I did? So we should go back to your first question then. Let me dig through your work. Is it this work here?
Yeah, change it.
So, and I'm okay even if you used a 10/4.
Right.
Okay, so if you change it to 5/2, where is it here? So negative 5/2 x, and then here's where it happens. If you put a negative 5/2 right here, what's negative 5/2 times negative 8?
Oh, negative.
So negative times a negative has to be positive.
Yeah.
And then what's 5 times 8?
40.
So this should be 40/2. That's where your mistake happened. I'm not sure where the 13 came from. 10/2. Interesting. I'm not sure where the 16 came from either. But now, like, we're okay. So this is 40 halves. Is that a 2? Because remember, it changed from, like, the numbers changed, and that's, I think, where you're getting hung up. Okay, so here's the deal. I'm going to make a claim here. I think that y is equal to negative 8/9 x plus 116 ninths. But I also have a second opinion, and not really an opinion. I have a second thought. Y is also equal to this. Now, this always seems like a silly statement to make, but it's nice because we're in geometry and we can actually use the reasoning. Give me guaranteed what y is equal to via the reflexive property. Does everybody agree that y equals y? And all I have here, I can certainly write that. And this is like the last step. We found these two equations. I think that it's true, and this feels dumb to write, and I wouldn't normally write it. But can we all agree that this is true by the reflexive property? Like, it's obvious, right? But here's the cool thing. Give me a version of y right now. Here's a way to write y. Give me another way, Carson, to write y. And then I'm just going to justify. We're not really doing a proof or anything, but I do think it's nice. All I've done, if we want to make it look proofy, is we just substitute it because I know what y equals. At this point, do we have a single equation? Yeah. And can we solve it? And I'm going to actually help you guys solve it. I'm going to move this stuff over just so I can keep it kind of from getting out of hand where it goes. But where'd it go? What? Control Z, Control Z, Control Z. That was weird. Take that, put it here. All right. So I'm going to do that work right here. And here's my suggestion, because we might all do the algebra different, and probably will, because I didn't teach you algebra. You guys think this looks good or looks bad to deal with? Not rhetorical. Do you love the fact that this is what we get? What don't you like about it? So be more specific, because I don't think that every part of it's bad. But there's a part of it that I think is the worst. The fractions. Okay. Do you guys agree that'd be nicer if we didn't deal with fractions? Okay. To bust a divide by 9, what undoes that so we can get rid of the fractions? Multiply by 9. This side has a divide by 2. What undoes a divide by 2? So if I multiply this side by 9 and this side by 9, and then I multiply this side by 2 and this side by 2, is that the same as just multiplying both sides by 18? Okay, if you don't like that idea, we'll take 2 steps. I would multiply both sides by 18 would be my next line. But we'll take small steps because maybe we don't need the 18. Like maybe one fraction isn't terrible. If I multiply by 9 here and here, this side works out so nice. What happens here? 9 times this. What happens with these 9s? Yeah, they're gone. And I'm just going to write negative 8x. What happens with these 9s? They also do the same, right? They divide out. So it's just negative 8x plus what number? 116. Okay, on this one, we're going to get negative 45 halves x plus, let's see, 270 minus 9 is 261. Okay, decision time. Are we just going to accept that there's a single fraction, or do you now want to multiply both sides by 2 to get rid of all the fractions? Okay, so single fraction is fine. I want to solve it for x then. What do I do? How do I solve an equation like this for x? So I'm cool with that. And can I do 2 steps in one here? I'm going to add 8x. How should I write it on this side, Carson?
40 halves.
Careful. What's 8 over 1? I want it to be over 2.
Oh, 16.
Okay, good. 16 halves. What am I going to subtract from each side, Drew?
261.
Okay, so I'll subtract 261 from this side, and I'll subtract 261 from this side. And let's see, on this, nobody has a calculator out. I do. Yep, I'm worried more about the 116 and the 261. But yeah, I'm going to need that one too. This is negative 145, these two. On the left, so the x's are gone, we get negative 145 equals, and then let's just see what we get here. Negative 45 plus 16, 29. Negative 29. Over what? Okay. At this point, we are going to bust this fraction because we're trying to solve for x. What do you want me to multiply by? Just 2? Okay. I'm going to write down, I'll write yours down here in a second, but I'm going to show you what I would do. In my situation, this is what I would multiply both sides by. Weird. I would do this. Why? Yeah, on my next line, I'm going to have to divide by 29 anyway, but we can make it 2 steps. They gone. Let's see, negative 280, 290 equals negative 29x. Hey, that looks like it's going to shake out pretty nicely. When I divide by 29 at this point, what's 290 divided by 29? 10. Hey, check it out. X equals 10. Do we have this ordered pair yet? Now, notice it's not perfect because we just sketched it. I eyeballed it. What I know about this ordered pair right now is that that's a 10. And my picture's off, and that's okay. I have a sneaking suspicion that when we actually get y, it's probably going to be 4, and this was a right triangle, because that's the only situation where the orthocenter is on the triangle. But let's verify. If I know that this is x, how do I get the y value out of it?
Plug it in to the original equation.
Now plug in 2, and I honestly don't know if this is supposed to be one word here, or is it 2 words? Grammar help. I know that into is one word, but even in this context.
Yeah, I would say
Okay, thank you guys. It's so odd. I can speak pretty well, and I can write pretty well most of the time, but there's these little situations. I don't care which one. Which one would you guys rather plug into? The pink one? Okay. So let's see. We'll go to this one. I'm fine with that. If we plug in x equals 10, our equation would be y equals negative 5 halves. And I'm going to plug in a 10. We're going to make it orange so it stands out. Plus 29. Could we have elected to plug it into the other one just as easily? Yeah, and we would get the same number. So let's see. I think this is negative 25. And I'm just going to work this out. This is negative 25 plus 29. And what do we get? 4. So at this point, we have an x and we have a y. Here's where notation, the way we write stuff matters. Like, this is a big problem. This is uglier than the ones that I'll make you guys do with all the fractions and stuff, just so you're aware. I was trying to write the single point where these intersected. I found the x and I found the y, but anywhere here have I written a point? What is, if I want to write down a point, what does it look like? 10 comma 4 with the parentheses, right? So last little thing, we need to make sure we see at all what we're actually trying to find. And it took a lot of work. The Orthocenter. So because there's so much work that went into this, it would be a huge shame if we got all of this right and just didn't clearly state our answer, right? It would suck if I took a point from you after all this work. So let's just avoid that. The Orthocenter. The Orthocenter is where? Is at good buddy. Cool. And we have it. Now, there are other ways to do this problem. If we look at what happens and where the orthocenter can be, maybe we could have used an observation from yesterday to make this problem way quicker. Not laughing about the problem, I'm laughing about something else that just happened. As we go through, though, does this look like stuff you did in Algebra 1?
Yes.
Do you remember doing it in Algebra 1? No recollection. Fair. You? Sort of. Okay, cool. Here's the deal. I really kind of want to give you homework, but I only have 30 seconds. I'm not going to give you homework today. If I'm not here tomorrow, it'll probably be a homework day and part lesson. If I am here tomorrow, it'll probably be a homework day and part lesson. So I guess half dozen, one hand. Cool. Wrestlers, I don't want to see you again until after the Christmas break. Carson, I'll have your final graded by tomorrow. If it needs reflections or points back, shoot me an email once the grade's in. Do you check your grades? Okay, cool. I don't know. I haven't looked at it at all, just so you know. But we'll see you cool cats and kittens tomorrow. Maybe. Peace.